Okay, so let's start this live stream. So where did we left on the Vulkan tutorial website? Vulkan tutorial. Okay, so we are in the vertex buffers and we have done the staging buffer. So we are using the the best performance memory now. So we need to go to index buffer and do some indexing for our vertices. Okay, and yes, finally we are going to say goodbye to the boring triangle. I almost got sick of it. Okay, so the 3D meshes you will be rendering in a real-world application will often share vertices between multiple triangles. This already happens even with something simple like drawing a rectangle. V0, V1, V2, V3, V4, V5, V0, V1, V2, V3. So 0, 1, 2, 2, 3, 0. Okay, that lists vertices to be rendered, I guess. Drawing a rectangle takes two triangles, which means that we need a vertex buffer with 6 vertices. The problem is that the data of 2 vertices needs to be duplicated, resulting in 50% redundancy. It only gets worse with more complex meshes, where vertices are reduced in an average number of 3 triangles. The solution to this problem is to use an index buffer, and it also reduces the total data, the size of the mesh. An index buffer is essentially an array of pointers into the vertex buffer. It allows you to reorder the vertex data and reuse existing data for multiple vertices. The illustration above demonstrates what the index buffer would look like for the rectangle if we have a vertex buffer containing each of the 4 unique vertices. The first vertex one containing 4 unique vertices. Yes. The first 3 indices define the upper right triangle, and the last 3 indices define the vertices for the bottom left triangle. Index buffer creation. In this chapter, we are going to modify the vertex data and add index data to draw a rectangle like the one in the illustration. Modify the vertex data to represent the 4 corners. Okay. I would love to know what would happen if we didn't use the vertex, the indexing buffer. index buffer. New vim src/main.c. God damn it, why is always this? I get this message. Yeah, whatsoever. Edit anyway. Okay, so this is our vertices buffer. Let's make a copy of it. So copy, paste, and let's change the test to vertices old. Goodbye, little old triangle. Hello, little. Oh, excuse. Undo. Hello, little new rectangle. Okay, so we are getting a warning. Access element in array initializer. We need 4. Save and let's try again. Make clean, make run. Okay, so we need to have an index buffer to represent the rest of the triangle. That makes sense. Okay, so the top left corner is red, top right is green, and the bottom right is blue, and the bottom left is white. We'll add a new array indices to represent the content of the index buffer. It should match the indices in the illustration to draw the upper right triangle and bottom left triangle. Okay, copy, paste, and let's change it to a. This is an unsigned short. Nice. Indices. But what if it's more? What if we have more indices than what unsigned shorts can have? Because it doesn't have a lot, I guess. Indices. How much are those? 1 2 3 4 5 6 6 indices. It is possible to use either unit 16 or unit 32 for your index buffer depending on the number of entries in vertices. We can stick to unit 16 for now, uint 16 T for now, because we are using less than 65,000 unique vertices. Yeah, that's how much unsigned shorts can handle. Just like the vertex data, the indices need to be uploaded into a VK buffer for the GPU to be able to access them. Define two new class members to hold the resources for the index buffer. Vertex buffer memory, VK buffer, index buffer memory. Okay. So where are you, Mr. Structs? Vertex buffer and vertex buffer memory. The create index buffer function that we'll add now is almost identical to create vertex buffer. So we are staging in this one also. Yeah, we are staging, I guess. Yeah, we are staging. VK buffer uses transfer SRC and VK buffer users transfer destination. Yeah, we are doing staging. Wait a second, create index buffer under create vertex buffer. We are at 1496 lines of code for just drawing a simple triangle. That is Vulkan for sure. Okay, so create vertex buffer, create index buffer, and give it state. Okay, create index buffer, copy this, copy, and create vertex buffer, create index buffer, paste, and give it the state, pointer state. I need to change this name to renderer, but I want to do it for now. And we have a bunch of errors. Buffer size of indices multiplied by blah 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 blah. We don't need this. We only need size of indices, because this is C after all. Create buffer. This needs the state. And here's staging buffer. Memory pointer. Take the address. Device state dot device this is the data. We don't need that, we just need to give it the indices and state dot device. Okay, index buffer. This must create buffer. This needs the state. Absolutely. State and state and we need pointers. Get the address, and problems are solved. Index buffer, this needs the state, copy buffer state. Okay, and device node pointer, device node. Redo. How to do redo? Whatsoever. State device and state of device. Give us a node pointer instead of this non-defined keyword. Node pointer and copy buffer state. Parabim parabdum. We have solved all of the errors and the warnings, except for one in the return, because we shouldn't return anything. I mean, we should handle something like that, but I don't know. Maybe later. There are only two notable differences. The buffer size is now equal to the number of indices times the size of the index type. There are only two noticeable differences. The buffer size is now equal to the number of indices times the size of the index type. Either, oh yeah, this is what you have did in size of indices at 0 multiplied by indices dot size, and you are just explaining the usage of the index buffer should be VK buffer usage index buffer bit instead of VK buffer usage vertex buffer bit, which makes sense other than that the process is exactly the same. We create a staging buffer to copy the contents of indices to and then copy it to the final device local index buffer. They mean that we are creating a buffer that can be usable by the CPU, that the CPU can access it. Then we copy that buffer to another buffer in the GPU so that we have best performance, and after that we free the memory that's in the CPU memory. So yeah, the index buffer should be cleaned up at the end of the program, just like the vertex buffer. So vk destroy index buffer, vertex buffer memory. This one is almost at the top. Okay, save. Where are you? Clean up. Destroy vertex buffer, destroy vertex buffer memory, and paste. State and a null pointer. Null is just 0 at the end, so I really don't know if I did, but it must be a pointer. So maybe you can create a pointer, then set its value to 0. That way you can have a null pointer, I guess. I really don't know. I think it's possible, but I have never tried it. State using an index buffer for drawing involves two changes to record command buffer. We first need to bind the index buffer just like we did for the vertex buffer. The difference is that you can only have a single index buffer. It's unfortunately not possible to use different indices for each vertex attribute. So we do still have to completely duplicate the vertex data, even if just one attribute varies. So if we did change some vertices in the vertex buffer, we need to do a copy because we can't use we need a new index buffer for it. Is that what are you saying? The difference is that you can only have a single index buffer. It's unfortunately not possible to use different indices for each vertex attribute. So we do still have to completely duplicate the vertex data, even if just one attribute varies. What is an attribute? Attributes. Yes, what the fuck? Google Translate is absolutely trash. Atrocious. That's the word. Atrocious. Okay. VKCMD bind buffer, vertex buffer. And VKCMD bind index buffer. So first, bind vertex buffer. Telescope. Knife grip and bind vertex buffer. VKCMD draw command. Well, first bind the index for buffer. Command buffer state and 0 and vk index type unit 16. Okay. Vertex buffer state vertex buffer offset equals 0 and 0 1 vertex buffer offset command buffer. Okay, so an index buffer is bound with vk command bind index buffer, which has the index buffer a bytes offset, which has the index buffer a bytes offset into its, which is 0, and the type of the index data as parameters. As mentioned before, the possible types are vk index type unit 16 and vk type index type unit 32, uint 32, unsigned int. I don't know why I always call it unit. It's uint, but I call it unit. Just what I'm used to. Just binding an index buffer doesn't change anything yet. We also need to change the drawing command. The drawing command. We also need to change the drawing command to tell Vulkan to use the index buffer. Remove vk command draw line and replace it with vk command draw indexed. Static unit ins. Okay, 32. The fuck is wrong with you new thing? Okay, auto completion is dead. Right, quit. Read. No. Quit. Edit anyway. Telescope. VK command. Live grid. VK command. Draw indexed. Okay, indices dot size. So we need size of indices divided by size of unsigned shorts. U int 16-G. Okay, so this function is very similar to VKCMD draw. The first two parameters specify the number of the indices and the number of indices we are not and what? The first two parameters specify the numbers of the first two parameters specify the numbers of indices and the number of instances. Okay, we are not using instancing, so just specify one instance. Okay, the number of indices represent the number of vertices that will be passed to the vertex shader. The next parameter specify an offset into the index buffer using a value of 1 will cause the graphics card to start reading at the second index. The second to last parameters specify an offset to add to the indices in the index buffer. The final parameter specify an offset for instancing, which we are not using. Now run your program and you should see the following. Okay, I hope so. Save. And make run. Woo! Yay! Yep. It's a new thing. We are finally getting rid of that old triangle. It's beautiful. Yeah, it's beautiful whatsoever. Okay. You know how to save memory by reducing vertices with index buffers. This will become especially important in a future chapter where we are going to load complex 3D models. The previous chapter already mentioned that you should allocate multiple resources like buffers from a single memory allocation, but in fact you should go to a step further. Private developers recommend that you also store multiple buffers like the vertex and index buffer into a single VK buffer and use offsets in commands like VK command bind vertex buffer. The advantage is that your data is more cache friendly in that case because it's closer together. It's even possible to reduce the same chunk of memory for multiple resources if they are not used during the same render operation, provided that their data is refreshed, of course. This is known as aliasing, and some Vulkan functions have explicit flags to specify that you want to do this. But if we made the index buffer into the vertex buffer, what should we specify in this one? Where is it? Create index buffer. Where is it? It's in here. VK buffer uses transfer 30 bits. VK uses transfer bits. Here we go. VK buffer usage transfer destination and VK buffer usage index buffer bits. Like, what should we specify in this one? I know it's in the vertex buffer. When you create it, you need to use VK buffer usage vertex buffer bit. So is there a... Well, let's see. That means it doesn't auto-complete. Create vertex buffer. Vertex buffer bits. Usage vertex buffer bits. Vulkan core. Let's see. Did we include it? Include Vulkan core. I have included it. Vulkan.h. I think it's something for another time. Yeah, maybe another time. Okay then, this is the end of the live stream. So, goodbye.